I'm Alan Percy. I'm with TelcoBridges. I'm here with my friend Sergio Lopez, who joins us from Monterrey, Mexico. And today we're going to share a little story about how Marcatel used a new strategy called the Intelligent Edge to manage traffic at the edge of their network using network function virtualization and leveraging that to build some new services with it. So let's get started with just a little bit of background, and I'm going to turn it over to Sergio, and he'll be happy to answer your questions as we get to the end of today's session. So first, just to start with, what is the Intelligent Edge? And in a nutshell, we're just going to cover real quick, what is it? How does it work? And the use cases, and of course we'll wrap up with Sergio's use case as part of the story. So first of all, there's obviously challenges for you service providers. I obviously hear them from you folks all the time. And SIP, I think, has really sort of turned into what this telephone pole turned into. I'm sure no one put this telephone pole up and thought, oh, well, we'll just hang 150 wires off of it. It just sort of happened, right? This is actually on a corner of Quito in Ecuador. So walking down the street, just sort of looked at this and said, nah, you know, that pretty much looks like a lot of the projects I work on too. So I'm sure it probably looks familiar for you folks too. So anyway, one of the key things, of course, service providers tell us all the time is the agility. We heard it in some of the sessions earlier today and some yesterday about how important it is to compete with the OTT services and be able to deliver them. Certainly in managing that network traffic. Security and intrusion, we've heard I don't know how many presentations today about intrusion and attacks, including the previous session. And then, of course, moving on to reliability and scalability, reducing the number of SKUs that a service provider has. If a customer has an issue, it's nice to have a couple of units that are maybe in the white van that they can quickly replace it, not have to go back to the depot. And, of course, reducing the overall cost of any truck rolls. This is critical for them. So along comes this thing called network function virtualization, and I'm just sort of curious, how many of you folks are familiar with network function virtualization? Good handful of, excellent, that's fantastic. So as you probably know, it consists of these three core elements. There's a platform at the bottom, there's a management system on the right, and of course VNS, virtual network functions. I'd like to find the person who chose those three letters for all of those. Anyway, the software modules that ride on top of it, these virtualized network functions, can be firewall, router, and other elements. And we'll talk about that as we get going through this. And IDC, during one of the recent reports, forecast that these virtualized network function software modules, that this market will grow to some $16.4 billion in 2022 at an compound annual growth rate of 45.5 or 4%. So obviously, a huge potential market for these virtual network functions. Along with that comes the platforms, right? We showed in the first slide these platforms that this has to ride on, and a new category of hardware platforms come along that is either mu CPE or UCPE, depends on who you talk to. But the idea is this is a platform you put out at the customer site that can then not only terminate the network, but also provide a place for these VNFs to run. And they're flexible in the sense that the operator could push different VNFs out to the edge of the network based on what the customer's needs are, or new revisions of the software, or potentially new offerings that they might have delivered to the market. So it's not only just a platform, but it's also a place to manage and orchestrate. There's usually software embedded in them, and they seem to have quite a collection of orchestration software platforms, and of course a range of different processing resources, from relatively small CPUs and memory to significant amounts of processing power out at the edge. And some of the examples of VNFs that we're starting to see is application delivery controllers, right? Load balancers, web-based tools. We're seeing media servers, session border controllers go out to the edge, routing software, and probably the granddaddy of them all right now is SD-WAN platforms. That seems to be really what's driving this push more than any other application, along, of course, with firewall and router functions we showed earlier. So, a variety of VNFs are starting to brew through the marketplace, and if you've been looking at it, you know that they continue to grow. So it sort of brings a question too, which is this sort of core versus edge debate. And this is something that, we've been talking about pushing so much to the cloud, we sort of forgot about the customer prem and what do we put there and why would we put it there? Well, what's happened is the economics have shifted, and when Sergio explains his sort of situation, you'll see how the economics have sort of shuffled things for him, where it was going to be more expensive to put functionality in the core of the network, because those are obviously very different dependencies, then push it to the edge of the network. And by putting some functions at the edge of the network and using this whole CPE strategy, gave him better control over that particular customer and at a much lower cost for this particular solution. So what are some of the use cases? Certainly, we're starting to see it in mobile operators with picocells, and I suspect as 5G becomes more and more popular and gets deployed, you'll start to see this more common. Pushing small microcells out in residential, retail applications, public spaces, et cetera, putting some intelligence in this little box, so it's not just a radio, but it has enough intelligence to be able to protect itself from attack, or do some routing, or potentially, other functions out at the on the pole, actually, at the edge of the network. We're also seeing them in the enterprise, where because of requirements for example, PCI compliance and other things, that they can push encryption and other functions out to the edge. Maybe they want to be able to continue to process credit card transactions when network outages occur. And also, too, features like SIP trunking can be delivered in a secure method out to the edge of the network for enterprises. And these are all built out of these building blocks, these VNF building blocks I talked about earlier, and they usually get stacked together in what's called a service chain, combining the functions. And for example, here we're seeing, a layer 1 switching and routing, of course with routing and SD-WAN, and of course as you go up the layers, the protocol layers, you'll see greater and greater, heading towards layer 7 eventually at the top with the application. So. And again, it has the various functions, the traffic management, quality monitoring, all can be pushed out to the edge of the network. So with that, I'm going to turn it over to Sergio and let him sort of explain how his network works and why he chose to go to an intelligent edge strategy. And I'll swap with you, and you can, if you want to do that.
Okay. I think the microphone will be
okay.
Hello, everyone. Nice to be here. I come from Mexico, and my company is Marcatel. It's a service provider company who specializes in wholesale traffic, and we provide also internet and private links. But the case that we are going to talk about is the congestion problems that we have had in our network and how we managed to solve it. At the beginning, we started to have congestion in the signaling network because of our customers. We switched from wholesale traffic to call center traffic. And call center is not like regulated, or they don't care about the amount of traffic they put in the network, even if they have only a small amount of sessions allowed to send traffic. One of the problems is that they use autodialers, and these autodialers doesn't have if they are not properly configured, they can flood the network with bytes. So the first approach we had was to increase our core network in order to be able to manage more attempts per second, more calls per second. And this was successful at the beginning. But then, as we were having more customers, one of them was starting to misconfigure his autodialer. It will start like a snowball effect, because the core SBC will reject with 503, and then they will keep trying to terminate that call in a continuous loop that not only consumes resources in the core network, but avoids other customers to terminate their calls. So it becomes a huge amount of traffic that the core SBC is not able to manage. So eventually they crash and we start losing traffic.
Yeah, if I could just move this to your challenges slide.
Okay.
Yep, okay. Yeah, and you can see it up here if you want. So,
All right, those were the challenges. To be able to manage huge amounts of traffic from different customers and be able to find a solution which was not as costly as increasing the core, because expanding the core is very expensive. So we were also starting to limit the endpoints from customers. But even though the core SBC was still rejecting, and that process of rejecting calls also takes processing from the box.
yep.
Maybe next slide.
Yeah. Move to solution.
Okay, so we finally decided to move the contention not to the routing SBC, but to the edge. And that solution proved to be effective only when the edge is not as expensive as the core, because not all customers want to pay for an SBC to contain their traffic. So it was something that had to be added to the business case already approved some time before. So by doing that, by finding a cheap solution that could be able to be installed in a bare metal server or a CPE from other vendors that can host VNFs, we're able to contain from the edge the amount of traffic that specific customers can pass. So in this way, even though the customers try to flood the network with a huge amount of traffic, the SBC won't let that traffic to pass. They will contain to a specific amount of traffic, for example, 10, 15, 20 calls per second, or even 50 for big customers. But in that way, we were able to protect our core in order to avoid any crash, any failure. And that has been proved effective so far. That's the use case that I came to share with you.
Yeah. You included also to this block diagram by putting the SBCs at the edge. If you want to walk through that real quick?
Yeah, that's a representation of our core network. As you can see, we have a diversity, and we have an interconnection SBC, which holds the big amount of traffic for the IP trunking. And then we have a medium routing SBC, which diverts the calls to the interconnections. And those were the ones that were crashing from time to time if the customers were not properly limited. So at the end, we had to install the free SBC in order to be able to contain those limits, those CPS that the customers send, because they don't want to be limited, and so they flood the network with attempts with a lot of numbers that are not effective, but they are still trying to connect until something happens.
Yep. You also, too, you said that for customers that had existing CPE, you were able to add this server, but then you had, the new customers, and you started now looking at, for new customers, moving to using VNFs instead of just a bare metal server.
Yeah, because in that way we can provide the private link, the Ethernet link, and in that same box that provides the Ethernet, we can install a VNF in order to be more effective in in the solution. Instead of having two boxes, we just have one with the application installed in the specific part of the box, and it will work together. So that would make the case or the business case more effective.
And I think then you wrapped up with just one more block diagram, which is it substitutes the bare metal server with the CPE with the VNFs running on it. Yep.
Well, in that illustrations, we can see how the auto dialers can become very dangerous because if they are not properly configured, they send a lot of attempts.
Good. Okay. A quick summary of things. We'll move to some Q&A. But in a nutshell, what Sergio was able to do is to use by pushing software out to the edge of the network and using VNFs, was able to then manage the traffic at the edge, plus provide protection for his network at the edge of the network, and eliminate traffic before it even got into his network. And that way, you were able to keep the customers below their calls per second based on their SLA. It prevented one customer from taking out, one of his core SBCs, and it kept everybody honest, and it financially made good sense for Marcatel. So, with that, I guess any questions?
There are other advantages from moving the intelligence to the edge because we can also route from the edge. For example, doing like a rotation, a number rotation for some call centers that ask for that, and instead of having that routine in the core network, we move it to the edge, and in that way we liberate processing from the core boxes.
Yep, question way in the back right there.
Now, what do you use for your orchestration, network management orchestration?
Well, do you mean the specific vendor we use in the network?
Yes.
We use Ribbon. We used to have a Gemban and in the routing section and Sonos in the interconnection section, but now they are the same. They are Ribbon.
And the VNFs are going to be managed by the Sienna.
Yeah, the VNFs are to be installed on CN equipment or a bare metal server.
What are the costs for deploying something like that, for like a ESPC or something like that on the Sienna with the hardware?
It would be like $3,000.
Quick and easy answer. Yep.
It would depend on the amount of sessions, but fairly more, it would be something like that.
Yeah.
Anyone else? Going once? Going twice? Thank you, sir.
Great, great. Well, we'll be here. Yep.